Hello, everyone. Good afternoon. Thank you so much for joining. We'll just wait 1 or 2 minutes to allow everyone to join the webinar, and then we'll get started in just about 2 minutes. Thank you. Okay, I think we can get started. Good afternoon, everyone. Thank you so much for joining the Flow Batteries Europe webinar, Europe's Path to a Complete Flow Battery Supply Chain. My name is Jesse Terry. I'm a policy officer in Flow Batteries Europe. And with us today are Anthony Price, Yuri Vrana, Tom Gebauer, and Matt Harper. And they will tell us a bit about European supply chain before going into a discussion and Q&A moderated by our Secretary General, Anthony Price. So as mentioned, this webinar is organized by Flow Batteries Europe. We are a members-led trade association based in Brussels, currently comprising of 33 companies and institutions, where we represent flow battery stakeholders at the European level. We're working to shape the regulatory framework for flow batteries at the EU level and contribute to EU decision-making process. You can see here our 33 members that we have as of now. We have members covering the full battery supply chain from raw materials to component manufacturers to battery manufacturers, as well as flow battery users. And today we'll have the opportunity to hear from 3 of them tell us about the European supply chain potential for flow batteries. First, we'll start with an introduction from Anthony Price. Anthony Price is the founder and director of Swan Barton Limited and Secretary General of Flow Batteries Europe. Anthony has worked in the flow battery sector for more than 30 years, starting with commercialization of Energy's flow battery development. Swan Barton is a consultancy company providing support to clients across a range of storage technologies, including flow batteries, sodium sulfur, and other storage systems, focusing on both large-scale systems and behind-the-meter and microgrid applications. Please, Anthony, the floor is yours.
Thank you very much, Jesse. So we're here because we want to discuss flow batteries, and flow batteries are an integral part of the energy storage system. Not all energy storage is batteries. Not all batteries are lithium. The flow batteries are a class of batteries that have many attributes that make them beneficial to the whole system. Within Europe, we face many challenges. We've got our economy to look after. We've got to provide secure and safe and reliable low-cost energy, and we need to be competitive. So what we're trying to address today is to look at how flow batteries can work within the European context. They're safe, they're scalable, and they can provide long-duration energy storage. And over the recent years, we've seen a major shift towards long-duration energy storage to be an important part of the whole energy system. This had been a change from some of the earlier battery systems, which relied on high power, short duration storage in order to receive income from high value ancillary services. We're now moving into an area where we need longer duration storage in order to balance energy over the longer term and provide a secure, scalable and sustainable system. If we use flow batteries in the right way, we can achieve that stability. We can provide a more resilient energy system. We can incorporate more renewables. And we can have a reliable and safe and secure source of battery technology. Grid stability and resilience is of prime importance to Europe and indeed to every power system. And as we change from traditional forms of generation reliant on fossil fuel and large rotating masses towards wind and solar, we're going to need to ensure that we've got a secure, resilient system that is able to meet the demands not only of today, but tomorrow, and the demands that our children and grandchildren will expect from us. We're going to hear a little bit today about why people would choose flow batteries. If you look at the basic chemistry of them, you can see that they should have a long lifetime. The materials are readily accessible, and that means that they can be cost effective for large-scale applications, and particularly for those applications which demand long-duration storage. Inherently, they can be non-flammable and safe because they're using non-flammable and safe materials. And this, along with recyclability, adds to a sustainable way to incorporate more renewable energy. Next slide, please. We're seeing flow batteries used around the world for a number of applications, and we'll hear about some of them today. Long duration energy storage is gaining in popularity. Many installations across America have a minimum requirement for 4-hour storage, and we're seeing 6 hours, 8 hours, and even longer being accepted as commonplace. The ability to use long duration energy storage means that we can balance loads. We can stabilize energy management across the whole day. This not only means that we can absorb large amounts of energy, but we can use them for reducing our peaks. That gives us savings on our transmission and distribution networks. Industrial users can use long duration storage to ensure that their energy supply is reliable. If they require uninterrupted power, the long duration gives them that confidence that they can be assured of a reliable, secure system. This is particularly important in many manufacturing plants, as well as data centers and medical centers where life support systems are critical. Off-grid and in remote microgrids, we need to be able to provide clean energy. In many cases, this is produced locally from wind and solar. So having the ability to use long duration storage means that these microgrids and off-grid power supplies can often be completely free of fossil fuel. We're seeing that data centers are increasingly being talked about as a most important part of infrastructure. We need them to keep the computers running, which seem to keep the whole of our industrial, commercial, and domestic life going. As data centers become larger and larger, the requirement to ensure that their energy supply is buffered and protected becomes more important. And we'll be talking about that not only today, but in future webinars. The next slide, please. Flow batteries in Europe will bring a number of benefits to us. We've talked a bit already today about the purpose of long duration energy storage. That means that we can reduce traditional balancing services, often reliant on diesel fuel or gas turbines, and replace them with low carbon alternatives such as energy storage. That gives us the ability to have a secure and low cost source of energy. Running storage and generation together can be lower cost than just running generation on its own, particularly when peaking generation is required to meet an uncertain load profile. This leads to increasing the security of electricity supply, and a secure electricity supply is vital if we are to keep infrastructure working in the way that it's intended. But it's not only on the production of electricity that sustainability is important. We need to look at where the materials come from, how they're used and how they're disposed of. And most flow battery systems will have a very high level of recyclability. And that means that the whole flow battery cycle will be circular in nature with a high degree of recyclability and reuse. All of this could be good news for the EU. It means that flow batteries can have a European supply chain. We can manufacture them in Europe, probably at very low cost, and that will help us reduce the trade deficit on battery imports. At the moment, most lithium-ion batteries are imported, and the deficit is enormous. We're reliant on not only importing the current stock of batteries, but also their replacements, which are probably required every 8 or 12 years. With a much longer lifetime battery, that replacement will be more spaced out, and we can use our batteries in a more appropriate way to ensure that we've incorporated more renewable generation and using its energy wisely. Next slide, please. We believe in Flow Batteries Europe that the EU has got access to the metals and organic materials, as well as the capability to develop its manufacturing capacity so that we can produce flow batteries, including their electrolytes and their components, within Europe. Growing demand for a safe, long-duration energy storage means that we need to increase flow battery production to meet this demand. Otherwise, alternative means of energy storage, which may be less sustainable, less recyclable, and less dependent upon European sources of materials and products, will be used instead. If we can strengthen our supply chain, however, we can strengthen the market, enhancing not only energy security, but also increasing the domestic content of the battery industry. Next slide, please. I'm now going to introduce Jiri, founder of PinFlow, co-founder of PinFlow, who's going to talk to us about the supply chain requirements for meeting quantity as well as quality. Jiri.
Thank you very much, Anthony. Maybe when I will follow your talk, you have forgotten to mention that flow batteries are actually pretty simple because technically it is about having two tanks with electrolytes, and these electrolytes are the carriers of energy, and they are pumped into the battery stack or reactor where energy is stored or released. And what we have here in Europe, we have everything what you need to have to build flow battery. And this is the advantage globally, that you don't need to have much things to build flow battery. You need to have some kind of regular manufacturing engineering, some pumps, plants of components, and so on. Then you need to have some mineral resources or maybe some electrolytes that can be also organics, whatever. And then you need to have some active materials to build battery stacks. And this is the thing where I would like to spend a little bit more time. When you are building the battery stack, you need to have membranes, you need to have electrodes. And we can produce these things also in Europe, but there are some challenges that must be handled. And maybe we can go for the next slide, please. There are some issues with those materials, actually. When we look, for example, on electrodes, they face to some kind of inhomogeneity. These materials are critically important for proper function of flow battery. Customers would like to have stable, simple, cheap solution, but it is on us, on manufacturers, to deal with all of these variances. When I compare, for example, some electrolytes and their composition, they might also significantly differ. Can we go for the next slide, please? Well, it is sometimes given that there are multiple chemistries or different suppliers, and also different manufacturers require something different. But I have a little bit feeling that it is creating some kind of stress also on manufacturers of active materials. Sometimes also there is inconsistency in quality of batches of different materials. For example, we observe this sometimes in membranes. Sometimes it is very tricky to properly activate carbon felts. And we would need maybe to have broader engagement and strict collaboration with suppliers, maybe some definition of rules, how to set up the products properly, that all parts of the supply chain and mainly the customer at the end of the day will benefit from the standardization. Can we go for the next slide, please? Yeah, here we have some example how we are testing the materials in real stacks. We are using method that is called electrochemical impedance spectroscopy, and we connect the whole battery stack to this, and we see immediately what are making the active components inside the stack. Can we go to the next slide, please? Yeah, in this benchmark study that I'm introducing, we are utilizing that we can easily connect the battery stack simultaneously. All the cells we can connect to that electrochemical impedance spectroscopy. And when we will get to the next slide, we can see that we can immediately gain the data from one battery. But this setup is pretty comprehensive, and this measurement is running on the whole stack. From our perspective, if it would be nice to have some kind of defined protocols that also manufacturers could benefit from individual testing protocols for all components. And when we will go to the next slide, that compares the data gained from a large stack with some small laboratory sample, we can simply see that you can easily set some methods that you can measure and immediately provide feedback that gives some information if the material is reasonable for use in flow battery or not. What we think in PinFlow, we think that some kind of standardized protocols allow meaningful comparison for different materials. And this could maybe support transferability between different laboratories, vendors, but also between different scales of flow batteries. So at the end of the day, it could enable regulatory market and grant some kind of compliance. When I go to my last slide, maybe I can highlight that this kind of stakeholder collaboration is truly needed because at the end of the day, it is about our customers. We are capable to manufacture all parts of flow batteries here in Europe. We have the resources, we have the industry, and we have the experience. But we need to mitigate the risks and benchmarks, build trust according to our experience. And helping to verify what is important in flow batteries, which parameters are crucial. It can also help to different parts of the supply chain, especially to manufacturers of those active materials. Yeah, and it could help really to stabilization of our grids based on flow batteries and also to our flow battery field. Thank you for your attention.
Thank you very much, Yuri. We will next hear from Tom Gebauer, CEO of Redox One. Redox One manufactures iron chromium flow batteries for the large-scale energy storage needs of businesses, industry, and electricity networks. Tom has over 15 years of experience in the alternative energy sector and a passion for developing and implementing innovative solutions that address the global challenges of climate change, energy security, and sustainability. Go ahead, Tom.
Thank you. Let me start with a brief introduction to Redox One. From mine to megawatt, that is basically our slogan, as we are covering the whole value chain from the raw material to ultimately selling batteries, deploying batteries, and ultimately also operating the batteries itself. We are a subsidiary of Teresa PLC. Teresa PLC is a Cyprus-based integrated resource group, mining and beneficiating chromite ore and platinum group metal ore. And the beneficiation is important because Redox One is one of the core activities in this field, as we are beneficiating the chromite ore and making iron chromium electrolyte out of this ore, and then ultimately putting this to good use in flow batteries. Redox One is the developer of iron chromium flow batteries and hybrid storage solutions, and we are also operating the storage solutions ourselves. In addition, we are manufacturing the iron chromium electrolyte. We have our headquarters in Cyprus, a development center in Germany, and we have a testing center and then an electrolyte manufacturing plant in South Africa, very close to where we are mining our ore. At the moment, we are having a manufacturing partner in Asia for all the hardware-related parts of a flow battery, and we are planning to deploy 210 megawatt-hours of flow batteries between 2026 to 2028, mostly in remote mining environments. You see here on the right side, you see our mine and the first installation deployment that is scheduled for the next year for a flow battery very close to the mine. We have in the middle, you see a picture of our electrolyte manufacturing plant, and at the bottom, you see some of our flow battery containers. Next slide, please. Here's a look at the European supply chain for alternative electrochemistries, specifically here looking at iron chromium flow batteries. And keep in mind that this is basically a look at the European supply chain from someone who is focusing right now on manufacturing the electrolyte and developing the hardware. This means we are very reliant on a very good supply chain for all the parts that are related to all the hardware components of the battery. So this is very important for us. That's why I'm very happy to share my thoughts on the state of the European supply chain. I've divided this here into basically the core components of a flow battery, the raw materials that are needed for manufacturing the electrolyte manufacturing itself, stack components, stack assembly, software part, and the balancing plant. Let me first talk about the raw materials. I don't see any issue with the supply chain in Europe. We have access to European-owned non-critical raw materials. They're all available, and I think this is true for most of the other raw materials that are needed for vanadium flow batteries, organic flow batteries, and similar. When it comes to the economics, most of the raw materials they are priced according to market prices. So here we are as well in Europe. We are competitive. So raw materials is not an issue from my point of view. When it comes to the electrolyte, making the electrolyte, the situation is a little bit different here. If you look at the manufacturing capacity for electrolyte, we still need scale for manufacturing this. In our case, I have to say processing is a big issue when it comes to scale, because at the moment we are manufacturing the electrolyte not in Europe yet. Why is it so? Well, first we need to build an electrolyte plant that we have in our roadmap, but scale is needed. And you see in Europe, if you want to manufacture electrolyte, that you have to deal with higher costs than probably in other geographies. Why is it so? Most of the energy costs are quite high in certain areas, especially in Germany. some chemicals that we need for the electrolyte processing, like HCl. They are slightly more expensive in Europe than elsewhere. And what we see here is when it comes to electrolyte manufacturing, by setting up a greenfield or brownfield plant, you have to deal with quite a lot of regulations in Europe. This is something that you have to deal with it, that you have to look at. And this is probably something that we would wish that the European Union, the authorities, and so on could help with, and of course partners when it comes to setting up manufacturing plants. Let me have a look at the stack components, and I think we all agree that stack components are readily available in Europe, whether it's membranes, whether it's felts, whether it's other components of a stack. There's no issue with the supply chain here. What we see sometimes is, especially for our kind of electrochemistry, that scale is needed for certain stack components, and we see a little bit of higher cost, which is probably due to certain scale up needs that we have. But in general, stack components are readily available. Probably a little bit costlier than other geographies, but it is there. When it comes to the stack assembly, stack manufacturing itself, capacity for stack manufacturing is available in Europe. What we see is that the capacity for larger stacks, production capacity for larger stacks, that's still missing. And what we don't see that much in Europe is a lack of pure play stack assemblers, which is something that we would be very interested in to discuss. And we also sometimes see that many of the stack assemblers are lacking a little bit of automation in the manufacturing process. So same here, scales. It's very simple. Scale is needed, and costs are a little bit higher in Europe. When I look at the software that is needed for manufacturing and deploying flow batteries, there's no issue with manufacturing or programming. It's readily available in Europe, whether it's a BMS, EMS, so we don't see any issue here. And also when it comes to the economics, no issue at all. This is not a concern for us. And then ultimately, or finally, if you look at all the balance of plant, which deals with tanks, containers, pumps, tubings, and so on, manufacturing capacity is readily available. You get all components that you need for this. What you sometimes see is that scale is needed in terms of can you get the amount in the numbers that you are needed, and in terms of cost. So we see here that the costs are slightly higher still in Europe, which is probably due to the fact that scale is sometimes not where the whole industry would love to see this. The next slide, please. Just to summarize this, basically our look at the European supply chain for flow batteries using alternative electrochemistries, in our case, iron chromium. So the European flow battery supply chain is developed. There's no doubt about this. But from our point of view, scale is needed. Less regulation for raw materials and chemicals processing is needed. Lower cost. Most of the flow battery manufacturers would agree with this, and a more speedy execution sometimes from suppliers would be highly welcome. But we see from other geographies that execution is much faster than in Europe, whether it's getting hands on toolings for plastics and so on. All the toolings, they are readily available in other geographies. So these are my 5 cents to this topic. Last slide here. So happy to hand over to Matt.
Thank you, Tom. Up next, we'll hear from Matt Harper, co-founder and president of Infinity Energy Systems. As president, Matt is responsible for the development, commercialization, and deployment of Infinity's groundbreaking energy storage solutions. Previous roles in his extensive experience in the energy storage industry include co-founder and president of Avalon Battery. Go ahead, Matt, the floor is yours.
Great, thanks so much, Jesse. And thank you all for being here today. Wonderful to be part of this event. I'm just going to give you a quick overview of Invinity, who we are, what we do, before I give a bit more context about how we think about our supply chain and especially how we apply that supply chain in the European context. Invinity are a global leader in non-lithium energy storage systems. We make vanadium flow batteries. We, over the last few years, have deployed over 1,500 of our individual flow battery modules. Every one of those modules is a totally standalone turnkey device. And what that's given us is it's given us a tremendous amount of experience in, not only how these individual devices come together and can be operated, but, the data set that we have coming back from the field now from all of those individually operating flow batteries is a really tremendously powerful resource in terms of the continual optimization and improvement of those products. We have done some of the largest flow battery installations currently operational in the world, with about 190 megawatt hours either operational or in various stages of deployment. Next slide, please. Invinity was formed 5 years ago by the merger of Avalon Battery, which I had founded on the west coast of North America, with Red T Energy Systems, which was based in the UK. That gave us a pretty global footprint. It focused on the North American west coast, the UK, with manufacturing capabilities over in Asia. Today, we deliver our projects around the world from one of our manufacturing sites, depending on where those products are going. For North America, we deliver primarily out of our factory in Vancouver. For the UK and EU, those products come in general out of our production capabilities in Motherwell, Scotland. And then from Suzhou, we do a lot of our balance of system manufacturing for the globe, as well as final product delivery to Asia and Australia. Next slide, please. Just to touch briefly on some of the projects that we deliver to and who are using these devices, we sort of span the full scope of applicability of energy storage in our view, with the exception of residential systems, which we don't touch. We sell primarily to utilities and developers who are either using the batteries as a standalone device to regulate certain portions of the electric grid, providing grid services, for example, or where they're using our batteries as a way to improve the interconnection of renewable generation onto the grid. We've also got a steadily growing fleet of commercial and industrial customers who generally are consumers of energy, often have some form of self-generation on their own sites, but in general are looking to decrease their electricity bills. And then finally, we touch on off-grid and microgrid projects as well, where typically a battery is being used to not only form the grid on a particular site, but then provide a balancing service between whatever form of generation is available. Again, often solar PV or other small-scale distributed generation, and whatever load is being served on that particular site. Next slide, please. This will be familiar to many of you in this room, but just in general, the structure of how we put one of our batteries together is that we put every one of the devices and components that is needed to form a fully functional flow battery inside a 20-foot shipping container. Every one of these boxes includes not only the sort of power conversion in the cell stacks, not only the energy storage in our electrolyte tanks, but also the supplementary systems like control systems, cooling systems, more esoteric technical things like shunt current mitigation. That you would definitely see in a flow battery plant, but totally integrated together in a product that is fully tested and fully functionally tested before it ships out to our customer site. That means that these devices can be dropped off on those facilities, commissioned within a relatively short period of time, with a very high degree of certainty on their ultimate capability, and then brought into service as quickly as humanly possible, often within days, if not weeks, of their initial arrival at site. Next slide. These are some of the projects that we're currently looking at. We've built a lot of projects in the sort of, tens of megawatt hours to date. As I'm sure many of the people in this room are, we're starting to look at much larger projects in the sort of tens to hundreds of megawatt hours and even beyond that. What you see here is a rendering that one of our customers has used as a submission for planning permission for a multi-hundred megawatt hour site in the UK. What we see, of course, is that as Anthony said earlier, the grid is starting to demand longer and longer duration energy storage. The grid is also starting to demand higher and heavier duty cycles out of those storage assets as they're being delivered onto the grid. And in our view, that combination of very heavy throughput with longer duration is something that our vanadium flow technology is ideally suited for. Next slide. Just to touch on our current product generation, what you see here is what we call Endurium Enterprise. Endurium was the product that we launched about a year ago. Enterprise is the variant of that is designed for behind-the-meter applications. Obviously, I'm not going to get into any of the specs, but they're all there if you want to take a look at them. But the thing that I would again emphasize is, the thing that we focused on from day one when we founded the company over 10 years ago was how do we turn this class of technology into a turnkey device that can be delivered on site and brought online very, very quickly. Taking advantage of sort of the factory built nature of the product to get ultra low cost and the highest possible quality. And that's a philosophy that it flows through to the sort of standardized configurations that you see that we're delivering to the site to sites around the world today, and that you see on this page. Next slide. So when we look into our supply chain, again, we've got a relatively standardized supply chain because of that sort of factory built nature of our product. Whether we are doing final assembly of our products in Motherwell or Vancouver or Suzhou, it's all built to the same drawings, built to the same specifications, built using the same global supply chain. What we focus on a lot, not only in preparation for some a growing book of business here in Europe, but also for some of the other jurisdictions that we serve, is how can we localize a significant portion of that manufacturing. And that localization is not necessarily just because of some of the stipulations around domestic content that we're starting to see crop up in solicitations around the world, but really it's a way of truly minimizing costs within the system itself. Just as an example, when we look at the electrolyte that we blend into these products, inside every one of those 26-ton shipping containers, about 18 tons of that is in the vanadium electrolyte. If we are able to blend that material relatively close to where our factory is, or relatively close to where that product is ultimately going to be installed, we can save a tremendous amount of money on the logistics costs of within our supply chain, and in terms of getting the product onto the site at the lowest possible cost. So, if you look through our supply chain overall in the European context, a lot of the electroactive materials, the stack components that Tom was talking about a few minutes ago, a lot of those are already produced for us in Europe, and where they aren't, we are sort of actively discussing how we can expand that kind of manufacturing capability. In terms of the electrolyte itself, vanadium is a pretty broadly available material. Where we are getting that material today is primarily not within Europe, but there are significant European sources for the vanadium oxides that we ultimately blend into the electrolyte. In terms of that electrolyte blending itself, we do have European sources for getting that electrolyte built. And I would say that, as we look around the world, the relative competitiveness of the blending of the electrolytes is not too geographically specific. It's not rocket science to go and blend the electrolyte, provided you have the right constituent inputs, provided you have the right quality controls. And ultimately, when we look across geographies, we probably see cost differentials of only a few percentage points between electrolyte that's manufactured in Europe versus electrolyte that's manufactured elsewhere. So that particular portion is I think very highly portable. Certainly some of the components like string balancers and controllers, some of the software that goes into the battery obviously is relatively transferable, and can be done locally relatively easily. I think that the place where we see differentiation from a purely regionalized sourcing strategy is on some of the balance system components. It's been a very long time since there has been a domestic manufacturer, a significant domestic manufacturing capability around shipping containers in either North America or the EU. And in fact, I don't think there was an EU when the last time there was a significant amount of manufacturing capability for those shipping containers. Does it make sense to try and bring that industry back to support something that we need? I don't think so. Right? We need to be sort of pragmatic as an industry about where we are sourcing certain components, and especially where some of those components are easily moved around the world, easily sourced from a number of different countries at relatively low cost, and where we can use them as a relatively small portion of the overall cost of our total product. We believe that there's great benefit in continuing to have to source globally from low cost regions, then bring those components in to do final assembly, utilizing some more locally sourced pieces of core technology as a way of getting to a domestic sourcing program or a localized sourcing program in North America or in the EU or in any other country, while still ultimately getting to the lowest possible total cost and while maintaining ultimately great product quality. Next slide, please. I'll just give a quick couple of case studies for some of the projects that we've built. As I said, we've got about around 190 megawatt hours of the projects that are either operational or in various stages of construction right now. If you go on to the next slide, I've got some of the European ones that we're working on that are maybe of interest to this group. About 3 years ago now, we went live with a project at the Energy Super Hub Oxford. This is a 5 megawatt hour battery that is providing grid regulation services onto the UK grid. Next slide. Again, looking at that behind the meter use case, we installed a project in late 2021 around the same time as we did the ESO project with a company called Scottish Water. Scottish Water was looking to achieve two things. First of all, they were looking to decrease their cost, their operational cost for one of their processing facilities in Scotland. Second of all, they were looking to decrease their carbon footprint. And so what we were able to do was to install an array of our batteries alongside a pretty significantly sized solar PV array. Those two things together are now providing power to the site 24/7, so that they can, again, make the best use of that self-generated electricity and therefore meet those cost reduction and decarbonization goals. Next slide. One of the larger projects that we had installed in the UK is one at the European Marine Energy Centre, or EMEC, up in the Orkney Islands. This is a battery that is in service taking tidal generated power and using that power ultimately to generate hydrogen. This is a duty cycle or an application that is one where, in our view, we're ideally suited to doing it, and where lithium batteries would never be able to do this service well, because regulating the power flow from a tidal generation source is something that changes 4 times a day. You are charging and discharging this battery 4 times a day in order to get to that steady, clean flow of power out into the hydrogen generation plant. That continuous duty cycle, as well as doing 4 back-to-back cycles a day, is something that our battery does uniquely well. Vanadium flow batteries do extremely well, and where we see those kinds of applications as a strong point of growth for us into the future. Finally, on the next slide, you'll see one of the projects that we are currently constructing right now. This is a project funded under the UK LODES, or Longer Duration Energy Storage Program, from DESNZ, the Department of Energy Security and Net Zero. This is a 20 megawatt hour project that is close coupled and in fact DC coupled with solar PV generation. The goal of which is to prove how batteries in general and our flow batteries in particular can deal with some of the overcapacity and the economic constraints that solar PV has putting power into the electric grid. With one of our batteries installed on this site alongside the solar PV generation, the time of generation of that solar PV becomes less of an issue. You can use the battery to make sure that that solar PV generator energy is solving some of the trickiest problems and really getting the maximum economic benefit of those solar generated electrons onto the UK grid. And with that, I think that's the end of my discussion. I will hand it back to you, Anthony, to guide us through some Q&A.
Thank you very much, and thank you to all our speakers. That's great. That's been a very useful introduction. We've had a few questions come in already, and some of them are very, very apt. I think there's a good opening question from Marlene, which I'm going to direct straight back to you, Matt, and then we'll go to Tom and Jerry for a comment. At the moment, what is the percentage of stack components that are sourced from the EU, and how do you expect that to change by 2027?
By value, it's certainly north of 50%. By number of components, there's a lot of like screws and washers and stuff like that come from lower cost sources. So it's probably a lower percentage. But look, it's the value that we're looking at.
Sure.
And I would say the majority of the electroreactive components inside our stack are either currently coming from European sources, or they are ones where we have European sources of material available as and when needed.
Thank you. And Tom?
In our case, it's zero. Sorry to say. We mainly source the stacks and stack component from outside of Europe.
Okay.
And it's cost factor. It's simply a cost factor for us.
Right. Jerry, you're very much in the smaller bespoke side of the market, but for you, what's the percentage that comes from Europe?
Yes, it's right. Actually, we are developing also the stacks. We are playing with different scales and with scale up of different systems. And we observed that there is pretty good supply chain in Europe. And there are companies that are producing new active materials. So we are very happy. And I'm absolutely convinced that you can build, let's say, battery stack that will be fully assembled based on European components. Of course, sometimes it is about research, sometimes it might be about how to bring it into praxis, and then it is the question of scale of production and availabilities of those manufacturers, but I see clear pathways how to get into those scales.
Okay, and then as an association, then putting our collective minds together, where do we think the European flow battery industry could be in terms of the proportion being sourced from within Europe? And let's deal, as Matt says, in terms of value, not in terms of number of bits then. So here you have to speak on behalf of your competitors, collaborators, and everyone else, both all of you. We'll start again with Matt.
Sure. If we look at the proportion of electroreactive components, electrolyte, assuming we do that blending in Europe, and then some of the power electronics components that also come from some of our partners in Europe already, we would be in the sort of 60 to 65% range pretty quickly.
Okay. And Tom, where do you think you'll be in a few years' time?
I would absolutely agree. It would be between 60 to 70%, yes. Mm-hmm.
Okay.
Mainly stack components, I would see as part of this mainly, and some of the and the electrolyte, of course. Yes.
Okay. Do we think that there's any issues in terms of the availability of these materials and components, both for their quality and their quantity? Are we going to be restricted in that in any way? Jerry, you've been looking a lot at quality processes. What's your immediate reaction?
I would really highlight that we can have really good quality products here. But maybe I'm sometimes a little bit afraid when the regulation will go, let's say, too deep. Specifically, I can highlight that polyfluorinated or ban on certain materials. For example, that membrane. I was talking about it when I was explaining the stack design. There are some materials that you would need to have to produce also for flow batteries, and those materials might be pretty difficult to exclude in your flow batteries. So sometimes in general, I would say that there are some specific parts that might be difficult to procure, and you need to look for alternatives. So I would highlight here that more research should be needed to meet specific targets.
Yeah, Anthony, I'd pile into that, and Jerry, completely agree with you. And I would say that it's an even trickier problem because in our case, usually what we see is that it's not actually components that are going into our battery. It's components that are going into the materials that our suppliers are manufacturing that are the biggest challenge. And so we're even operating at arm's length from so for example the control of some of these fluorinated chemicals, for example, and therefore don't have as much sort of direct impact over the regulation of those materials. I mean, look, I don't think any of us would disagree that some form of reasonable regulation is required, but also, holding us as a small, strategically relevant, and hopefully very quickly growing industry is one that I think needs to be balanced with kind of the long run goals of ensuring, environmental and health sustainability around how these products get manufactured.
Super. Tom, on your third, I think it was your third slide, and I don't know how quickly Jesse can help us find that. You had a nice little chart which showed the European supply chain, and you've got here, the typical greens, the amber, and the yellow. I guess it's the yellow because you didn't want to put that in red because it would have made it difficult to read. But let's just think in terms of this stack assembly. Why is that yellow? What have we got to do in order to create the capacity to make large-scale stacks? And what's missing? Have we got something wrong that we're not able to manufacture? To my mind, producing stacks is fairly easy. I mean, it's not something everyone can do, but we seem to have a huge plastics industry that can make injection molding components for cars, for trucks, you name it, we can do it. It's not much. Can't be particularly difficult. Why is there a problem, and why is that in yellow, Tom?
Yeah, I mean, the first thing is if you look at stacks that are being manufactured in Europe by pure play stack manufacturers, I mean, most of these are rather small. If you just compare it with stacks that you can get from other geographies, I'm talking about, I don't know, the maximum of 10 kilowatt stacks, right? That you see here, and we are looking at larger stacks. So that's one thing. I haven't seen a stack manufacturer that is able to manufacture larger stacks. The second thing is most of these, I mean, a stack has to be developed and designed to work with the system itself, right? And this is something that where a couple of the pure play stack assemblers that you find in Europe, I mean, they have developed their own stack, and the stack works probably very well by itself. But how does that very specific stack work together with a system that we, for instance, develop that needs to work with our system? So it should be possible, definitely, because the manufacturing by itself should be fairly easy. Everyone knows how to make a stack and a good stack. And European companies are making good stacks. So there's no doubt about this. The thing is, scale. I'm not aware of a stack manufacturer that is able to churn out easily, let's say 20 megawatts in terms of stacks easily per year at the moment in Europe. So scale is one thing, and the other thing is that stack manufacturers need to be a little bit more flexible when it comes to the specific customer design related stack design issues in terms of size, in terms of cell numbers of cells, what kind of stack components need to be in there, especially for iron chromium flow batteries. We need to use specific membranes and so on. So that's an issue here. It shouldn't be a big issue for the European industry because everything is there. And as you rightly said, Anthony, I mean, plastics, plastic molding, injection molding, everything is available. So it just needs to be worked on. That's all I can say.
But fundamentally, is there anything not to like about the fact that we would recover a manufacturing industry in Europe, which we've often seen decline because of high energy prices, because of competition from overseas suppliers? It must be at least one, if not two orders of magnitude lower cost to build a flow battery gigafactory than a lithium ion gigafactory. So why aren't governments falling over themselves to support the development of flow battery manufacturing?
Look, I believe the big issue is it all started with mobile applications for batteries, right? Mobile applications are close to everyone personally because everyone drives a car, right? And if you drive a car and you want to have an electric vehicle, you need a battery, right? And everyone is more familiar with batteries that are for mobile applications because it's end customer focused and so on. So I guess the authorities were very much focused on trying their best to fund and build lithium-ion battery gigafactories, and only later the issue of stationary energy storage, especially for long duration or for longer duration applications, came onto the radar actually, and I think this is something that we all need to work on. That the authorities, the EU, and so on, that they are aware. Hey, there is a stationary energy storage for longer duration is important, and this is something that that Europe can still own because flow batteries have been developed in Europe long ago, and we just need to build the factories and get support from the authorities and get funding. That's it.
So there is now the challenge which Matt alluded to. I think, Matt, if I heard you correctly, you're saying, we don't seem to be able to manufacture shipping containers in Europe. And I know we really bothered. That's a low value commodity item. If we can source them from elsewhere, not a problem really. But Misam raised a question about actually, how does Europe compete against the Chinese manufacturers who are already at incredibly high scale and incredibly high levels of production? Have we gone too far? Have we lost the race?
No, look, I don't think we have. And the path to winning that race flows through those critical components inside the flow batteries and getting them right and manufacturing them at the lowest possible cost where they are not already being built elsewhere in the world. If we think about our batteries, for example, in vanadium extraction, right? There's a tremendous amount of very compelling work being done in extracting vanadium from petrochemical wastes, for example. That's work that if you look at the projected costs of those processes, we could be seeing a fundamental step change down in the cost of vanadium production within about 3 to 5 years. That's innovative work that can be done here, that can be applied here, and that can drive down the cost of our product globally. That doesn't necessarily run through factories in low-cost regions. So, but does that mean that we should be trying to source absolutely all of the components inside our product domestically? No, absolutely not. I think it's a question of comparative advantage, right? What are the areas where European companies can innovate on delivering the critical components into these batteries, and how can the battery manufacturers turn those components around and make sure that they are competitive as compared with the existing products coming out of lithium batteries, lithium factories out of China.
Okay, so quite interesting your comments on cost, but also perhaps we should look at the value of flow batteries. Do you think that we've not really given enough benefit in our in our overall project analysis to the inherent value of a flow battery in terms of we're reducing the balance of payments, we're increasing recyclability, we're using indigenous materials, we're increasing the labour content and therefore creating those valuable green jobs, which we hear so much about. Have we got the story right in this area? I'll let you go first, Matt, and then I'll bring in Julie and Tim.
No, look, I mean, I think we as an industry have the story right. Are we shouting that story as loudly as we need to from as many rooftops as we can possibly find? Probably not. Certainly it is as we engage with politicians and other sort of regulators and policymakers, I mean that is exactly what resonates, right? How do we make sure that we are building a strong domestic industry that includes great domestic jobs? And how do we make sure that we are not becoming reliant on critical minerals and critical sources of supply for which we do not have control? I think we as an industry have a very clear perspective and a very clear concept for how those two things can be done in parallel with one another at the same time as leading to a fundamentally lower cost, fundamentally decarbonized electric grid. But getting out there and telling that story and repeating it as many times to as many ears that will listen is utterly critical if we're going to make a material dent in that future electricity system.
Thank you. Jury, have you got any comments to add to that?
Yeah, well, I would like also to highlight that we are unique here in Europe with all of that research effort that we were putting also into flow batteries. And it must be highlighted that flow batteries didn't have so many opportunities to grow and scale as lithium-based batteries, because the story, as Matt had mentioned, was caused by mobile electronics. And EU was helping to overcome these issues. And I would just mention that there is certain dynamics. The things are still alive, but when you are developing new stack that will be larger, cheaper, with lower flow resistance and so on, it will just take some time to verify the things, to develop the tools to manufacture the things. But there was a huge support, and I think the know-how is still here, and we are getting there. We are bringing new ideas to life, and we are there actually.
Tom, anything to add?
Yeah, nothing much. I mean, again, we can make it in Europe. That's this, and Europe has to make it because I mean, flow battery is probably at the moment one of the very, very few remaining storage technologies that is not so much owned by other Far East countries, right? And not so much dominated in terms of gigantic production capacities and costs, like in the lithium-ion battery space. So it's still flow batteries are the battery technologies, or there's vanadium or others that can still be heavily deployed, manufactured in Europe, and where Europe can still be a leader when it comes to technology development.
Okay, that's interesting. That's all good stuff. So we've got a really good story to tell emotionally as to why people should have flow batteries. Have we got the financial analysis to make it an absolute convincing case to investors who are often very, looking very directly at can they make a return over 7 years with guaranteed sources of income. Where have we got those income streams that give an investor confidence to invest in flow battery infrastructure in the EU? Who'd like to start? Gone quiet. Tom, where are the best business cases?
Look, I mean, I saw the question. I think it also came from Marlene, right?
Yes,
Who mentioned the bankability and is there a business case? Is there a business case for storage solutions for storage duration of something beyond 6 hours and so on? I mean, we at the moment we are looking mostly for applications where flow batteries really can make a difference. And these are mostly off-grid applications in remote areas and so on, where longer duration is needed, 6 to 8 hours. I think we as a flow battery industry, we need to make sure that we don't compete with lithium-ion batteries or sodium-ion batteries in every business case, because we will not be able to compete with lithium-ion batteries in all the different business cases. There is no chance. I'm not 100% sure if there are a lot of business cases in Europe where flow batteries and longer duration energy storage can make money. I know that for sure in areas where the grid is weaker and where the grid is not as developed as we know it here in Europe, there are business cases, definitely. So that's what we are mostly focusing on, these geographic areas. These are southern African, the MENA region, and so on. This is where we're focusing on. But the question is very right. There are not so many not so many compelling business cases where you can make a lot of money with a storage duration of 7, 8+ hours at the moment. That's my take. Matt might have a different opinion, or Jiri. Please feel free to comment.
Matt, come on.
Yeah, look, I was going to go in a slightly different direction on this. I mean, are we telling the story right? Yes. Are we up against the lithium juggernaut? Yes. What can we best do about that? I think a big part of it is making sure that we are out there and appropriately sharing information on how lithium batteries appear to be performing. We've heard a lot about how LFP is a real step change above some of the previous chemistries in terms of durability. There's also what I would say is a bit of a collective delusion within the developer industry, around how those batteries are going to perform over their lifetime. We heard recently about a project in the UK and that was in the hundreds of megawatt hours that is looking at a full replacement of the entire lithium battery array on site because it is no longer able to function. Those kinds of stories are the ones that we need to not be, we need to get data that we can put out in front of the wider market to be able to share why our devices are fundamentally more durable, fundamentally more reliable, fundamentally the kind of thing you really want to use as the backbone for the future electric grid, rather than something that you're going to need to buy from a foreign source every 8 to 12 years. And get that information out in front of the market, in front of our industry, in a way that is referenceable, that is data oriented, and that'll allow us to make a much stronger case for the kind of durability and low life cycle cost that we know is inherent to our technology.
Thank you. Just a little push here for Flow Batteries Europe, who are producing. I think we have already produced it. Jesse will correct me. A business case about a replacement of gas peaker plants with flow batteries. So there are numerous examples I believe, of where flow batteries can make a difference. And I think perhaps one of the things here is that we shouldn't try to use the same financial analysis tools for all the technologies on a power system. And I give as an example from my own experience. For years, we've been trying to get people to adopt battery technology of whatever sort. And one of the motivators was, well, it doesn't compete against the capital cost of putting in a peaking gas turbine or a peaking diesel engine. Well, it wouldn't, because those are very, very low capital cost. And of course, if you never use them, there's no cheaper plant to have as standby than having a diesel. So actually, that was completely the wrong way of analysing the situation. Once we started looking then at some of the frequency services, it only took a space of less than a year for people to realise that what was not a business case actually was an incredibly good business case. And they didn't even need long-term contracts. People were piling in to provide frequency and standby reserve to various grid authorities without any certainty of a long-term income stream, just because it was seen to be the thing to do. So the markets can change very, very quickly. And I think actually folk that are just looking for a fixed 7-year return haven't perhaps understood the true flexibility of having storage. And long duration energy storage is a completely different product to almost anything else that we've ever seen on the power system. So I think that it's a debate that needs to carry on. It's certainly a debate that we will be continuing within Flow Batteries Europe. And it will be one that will give, I think, investors some food for thought, and they should start sharpening their pencils, not trying to imagine what the outcome will be in 4 or 5 years' time without putting in storage, but to imagine what possibilities will be opened up if they take the option of putting in storage. So let's move on a little bit. Trying to keep an eye on questions that are coming through. There's one here from Hannes about specific development of electrochemically active materials. I'll read it out. How dependent are manufacturers on customer-specific developed electrochemically active materials? Are core components already bought from multiple sources? Are standard materials used? Jerry, you've got a good insight into standards and quality. Do you want to start off with this one, please?
Yeah, sure, that's great. So at our end, it is actually difficult because what we are doing in PinFlow, we are actively benchmarking all the available materials. We are trying to be really in close touch with developers of those materials. And we know that there are actually products that you can interchange, or that you can make the combinations of different electrochemically active materials, and you can actually benefit from those combinations. And some combination leads to some functional exchanges. Some things led to some kind of improvements, actually. So it is, I would say that this is one of the things that is really important and interesting. But on the other hand, at the end of the day, it will be maybe about the price and about the costs. And when you or when you would like to grow into scale as a manufacturer of flow batteries, you must be sure that your suppliers are stable and reliable. But maybe, Matt, what do you think about those things with supply chain of active materials?
Let's go on.
I think you can have any color you want so long as it's black. We do zero customization of any of the components inside our electroactive material set based on individual customer applications or individual use cases for the battery. We do modify the way that the battery works in some cases to, for example, if efficiency is critical, we can run at a lower power density, modifications like that. But in terms of the fundamentals of the material themselves, we operate on a totally standardized material set.
Okay. Can we just raise the topic of standards? Is there any activity that's taking place in the standards community that will have an impact on the supply chain, particularly the supply chain, growing the supply chain in Europe? Tom.
Well,
Can you please, didn't quite catch it yet. Can you please repeat?
Oh, sorry. We're talking about the process of standardization. Are there any activities taking place in the standards community at the moment which would have an impact on developing the supply chain within Europe for flow batteries?
I don't have that much of an opinion on this because but when it comes to certain stack materials and so on, where standardization is probably a bigger issue for the vanadium part of the flow battery space, because it's much bigger and you have more companies active there. In our case, since we're using a different electrochemistry, we are still basically evaluating most of the active materials in a stack. And also when it comes to the electrolyte for our chromium flow batteries, we are defining our own standard here in this case. However, I'm very sure that when it comes to the flow battery space, I mean, standardization is of course a big issue when it comes to active materials for vanadium guys. Having the same felts and membrane stuff all across the board is a very big issue. I'm not sure if this is really the case if all these standards are in place at the moment. I know that people are working on this, but many of the suppliers, but also of the customers, basically the flow battery manufacturers, they're still keeping their requirements for these active materials very close to their heart and not sure. Yes, exactly, Matt. Yeah, they're still keeping it for themselves, and I'm not so keen to share their requirements yet, which is sad. But hey, we need to deal with it.
Yeah, I think one thing of importance here is to note that the battery passport is an important part of future European legislation, and Flow Batteries Europe has set up a working group to look at the ways of calculating the carbon content, the carbon footprint of a flow battery, so that can be included in the battery passport, and that will be critical, I think, for demonstrating the inherent value of a locally made, locally sourced flow battery in comparison to other types of large-scale battery energy storage. We're rather hoping and rather expecting that the carbon footprint of a flow battery per usable megawatt hour will be somewhat less than that of a lithium-ion battery. If people have any interest in that topic, Jesse back at Flow Battery Europe headquarters is the man to contact. We'll be delighted to welcome you into the fold if you want to join that working group. Okay, we need to move on. We can see that we've had one very brief comment from Brett, that just talking about long duration storage, 4 to 6 hours works great, referring to a project in North America. I think it's that those simple statements of how flexible flow batteries are in providing long duration that will do a lot to help the cause. I think just checking on questions. Wow, there's a very complicated question here from David Hamburger. The import of graphite systems coming out of Asia, specifically China, how does the exporting rules of China in terms of graphite and graphite-based materials like bipolar plates influence the supply of those materials and parts to the European production of flow batteries? What does this change now? How do you see this, and how will this affect? Matt, you're probably using more graphite plates at the moment than anyone else. What's your view on the import of graphite?
Well, it assumes we are importing graphite, which I'm neither going to confirm nor deny. But look, I will say that this is the consistent question that we've been having to face all up and down our supply chain, especially over the last couple of years. As trade protections have started to become more aggressive, we've had to reconsider, all of these sources of supply and how they work. The one that you mentioned is not a problem for us right now, but certainly we have seen some very specific restraints, especially out of China. And like you need to find a way to work around them, right? Sometimes that involves, transforming the material into something different before it crosses the frontier. Sometimes that means that you need to work with your supplier to have a different source of supply. I mean, a large number of these, the suppliers for these kinds of materials are global companies or companies that at least have footprint outside of an individual country. And that's usually the first step for us, is to say, okay, if there is some sort of trade barrier being thrown up, what else could we do before we start to look at a wholesale change to our overall supply chain?
Okay, thank you. Where are we up to on that? Any other questions coming in? So, when we've been talking about flow batteries this afternoon, I think naturally our attention's been drawn to the stack and perhaps the electrolyte. In terms of the flow battery, of course, it involves much more. Involves the whole system, the power electronics, the battery management system, the pumps, the monitoring, the control, the SCADA, the integration, and indeed as well the value chain of the EPC, perhaps putting it all together. In terms of the overall content, then, what messages have we got for the industry, and messages have we got for local, national, and European governments about the value added that we can bring into the battery manufacturing industry in Europe? Who wants to start? Tom.
Look, I mean, what I would definitely suggest is that the EU implements certain rules and regulations when it comes to local content. That's always the best, and you see this in many other geographies, that a certain amount of local content is required. And in our case, very specifically, it's now for the iron chromium. I mean, you could easily say, okay, if we're just able to manufacture the electrolyte locally in the EU, that already makes a lot of the value there. And the biggest, actually, when it comes to flow batteries, whether it's vanadium or iron chromium. I think political support would help a lot if you would put these local content requirements in a legal framework. That would very much help the industry. That would also help the companies that require electrolyte to buy it locally. And if you have these local content rules, then there will be an industry that is going to manufacture these components at scale, and this should usually result in lower costs. And then you basically have this in place. That's my take on this. Why not implement these local content rules? You see this in many other geographies right now. So why not do this for the EU? At least it helps build up the industry in Europe.
Thank you very much. There's a related question just come in. I mean, we ought to just discuss in rough terms the percentage of value of a flow battery split between the stack, the electrolytes, and then the control system. So Matt, have you got some ballpark figures for relative proportion? And then can we just talk about vanadium supply, please?
Sure. Relative proportion, I mean, those are all the components that we would think about being able to domestically source. So again, I'd put it in the sort of 60 to 65% range, similar to what I said earlier. If I could just pile onto the last question briefly, I think in terms of the domestic sourcing and sort of the stipulations around it, it's important to note that we as an industry, I don't think are going to get support for that if we are the only voice pushing for it. And we're also not going to get support for it if what we are perceived to be doing is pushing costs onto our customers. So, for example, programs that say thou shalt source domestically sourced product is probably going to be a much tougher sell than something that says, if you're a developer and you're going to build out a storage project in some region, that the government will provide some form of support or backstop or low-cost financing or something like that. That means that the cost of implementing a domestically sourced product is not passed on to either the developer or the end user. We've seen in the U.S. where there's a great example of how domestic sourcing benefits flow through to project developers in the form of, manufacturers and project developers in the form of either production or investment tax credits. Those kinds of structures are good because in theory, and if architected properly, they can make sure that the cost to end users and developers doesn't change significantly. And if we can do that, then we are likely to get those parties on board with doing business with companies like ours rather than trying to buy product from overseas.
Okay. And just a quick word on vanadium. Have we got enough vanadium? Will the vanadium mines in Norway, which have been proposed, solve the European vanadium problem? Is there an issue?
The issue is not about availability. The issue is around processing, right? And certainly there are potential sources of vanadium all over the world that have been underdeveloped. There are also potential sources of vanadium through secondary. Secondary means, petrochemical wastes being one of the ones that I'm always interested to talk about, that are potentially massive sources of the material, but that need dedicated effort to start to explore, to start to industrialize. That's work that I think is likely to happen as we as an industry grow and mature, but it's not something that's going to happen overnight. So the sooner we can get some of those processing capabilities for the input materials into our batteries solidified, the better off we're going to be.
Super. Thank you very much. This afternoon, we've heard from our speakers, and we've had some insightful questions from the audience, which have led us to discuss the need to develop large-scale stack manufacturing in Europe. We've talked about local content and whether that will be a good idea to push or just to enhance or just to talk about it, and try and perhaps find a way of encouraging local, national or European governments to support local content. We expect the European supply chain the European supply chain at the moment is supporting perhaps 50% by value of the flow battery manufacturing in Europe. We expect the content to rise to perhaps 60 or 70% in the coming years. We've looked at the business cases. We talked this through a bit. There are a wide number of business cases. They're not all necessarily the same as other batteries. It's a different market. There are different markets, and the market is constantly evolving. So we need to look to the future in order to find out where the best places for flow batteries will be. There's no real issue with supply of any of our materials, components, or systems for flow batteries. What we really need to do is to ensure that we are using flow batteries in the best possible way throughout Europe to take advantage of their unquestionably valuable attributes which will help us to a sustainable, secure, and safe and reliable energy future. With that, I'm going to hand back to Jesse, who's going to give the final comments and tell us a little bit more about FBE's future activities. And of course, to thank all our Flow Battery Europe members who've joined us and all our guests today. So Jesse, over to you.
Thank you very much, Anthony. And thanks again very much to Yuri, Matt, and Tom for the really good discussion. So first up, we have another webinar coming up on the 20th of November on the topic of harnessing flow batteries to power data centers. So that's quite a popular use case, a popular topic that's come up again and again, this idea of data centers and the challenge behind the massive energy needs they present. So the topic of this webinar is to discuss, with some case studies as well, how flow batteries can be a solution to this to enable the development of data centers and to allow their connection on the grid. You can register already now on the link here, and you can find registration link on our website as well. And finally, this webinar was organized by Flow Batteries Europe, and we had the pleasure of hearing from 3 of our members in Flow Batteries Europe. So as a final note in this webinar, just to explain what's in it for you as regarding FBE membership, for those of you who may not be members here. You can get policy insights, of course, be part of our great network of members, as well as insight into upcoming funding opportunities and collaboration and the network to enable to really benefit from that funding and find partners within the network. If that's interesting for you, feel free to check us out on LinkedIn. We post daily. You can also check on our websites, and please feel free to contact me for more information on membership or any questions you might have about flow batteries or Flow Batteries Europe. My email is here on the screen, and you can also find it on our website as well. Thanks again to everyone for joining. Thanks again to our panelists, and we look forward to seeing you on the 20th of November for our next webinar. Have a good afternoon. Thanks.
Thank you. Bye.
Thank you.